Good evening, ma'am.
Good evening, ma'am.
Good evening. Okay, all are here today. Let's first recapitulate. Come on the screens, please. Put on your cameras.
Ma'am, homework done.
Hmm?
Ma'am, I have done the homework.
Yeah,
Ma'am.
yeah. We'll just discuss. You please come on the screen first. Bhavesh,
Yes, ma'am.
put on your camera, please. Okay. First of all, Adakshin, what is meant by electricity?
Ma'am,
What is electricity? Describe electricity.
ma'am, electricity is like we use some energy, ma'am. It's like energy we use for mobile, for tube, like fans, power, like that, ma'am.
Okay. Harshit, how is electricity generated? Harshit, how is electricity generated? Harshit, Neha?
Ma'am,
Yes, Harshit. Yeah, I can hear you now. Say.
Sources of energy.
How is electricity generated? Yeah.
It is generated by thermal power,
Hmm.
windmills, dams,
Dams. Okay.
and coal.
Coal. Okay. Great.
Ma'am, even biomass.
Fine. Okay. Now,
And solar power, ma'am.
solar panels. Very good. Bhavesh, you tell me uses or advantages of electricity. Apart from running of electrical appliances in our home, more uses of electricity.
electricity can be used. Electricity can be used.
Hmm.
Electricity can be used in many offices. It is used in lights, traffic signals.
For powering traffic
For,
signals.
for
Great.
and electricity is also present in generators.
It is
It's
present in generator or is it is generated by generators?
generated in generators.
Generated by generators. Okay. For installation of like television, AC, and other appliances, and for construction of roads and buildings. Okay.
Yes, ma'am. Ma'am, and is used in electric cars.
Okay.
Electric
Great.
cars.
Not only cars, now we have scooters also, electric scooters also we have, right?
Yes, ma'am.
Neha is left. Neha, tell me, describe a basic electric cell, cylindrical cell.
Ma'am, an electric cell is in a shape of a cylinder, and it has two sides. It has two terminals. Positive terminal, which is the metal cap, and negative terminal, which is the metal disc. which
Metal
is flat.
disc. Okay, great.
And the positive terminal is represented by a plus sign, and negative terminal is represented by a minus sign.
Okay, fine. So let's next move on. I gave you homework also to find out the types of cell and their uses. So who all have done?
Ma'am, me.
Raise your hands.
Ma'am, I have found the types of cells, ma'am.
Pardon?
I only found the type of cells.
Or it's okay, fine. Anything, at least anything you have done. Neha, Dakshin, Harshit and Bhavesh. Why not?
Mhm.
Ma'am, I did,
Ma'am,
ma'am. Ma'am, I
ma'am,
did.
ma'am, I know the shapes of cell, but I don't know their uses, ma'am.
It's okay, fine. So shapes of cell, you tell me, Bhavesh.
Shapes of cell are circle, cylindrical,
Hmm.
and ma'am,
Okay.
and
Okay, it's okay. Harshit.
Ma'am. Ma'am,
Any more types of cell you want to tell?
prismatic. Prismatic.
Okay.
Pouch.
Not getting.
Pouch, ma'am. Pouch. Pouch.
Okay.
Ma'am, button.
Button cell, okay.
Cylindrical.
Last is
Cylindrical.
cylindrical, okay. The action.
Yes, ma'am.
Any more stuff you have to tell about the types of cell and uses?
Ma'am, in toys, in smoke alarms, in medical devices, in electronic bikes, and consumer electronics, the etc.
Okay. And Neha?
Ma'am, can I tell the meaning of single A,
Hmm.
double A, and triple A? Ma'am, can I tell the meaning of single A, double A, and triple A on a battery?
Yeah, please.
Ma'am, a single A is smaller in size when
Hmm.
compared to a double A. Ma'am, they just state the size of a battery.
Correct.
So double A is larger than a single A, and triple A is larger than a double A.
Hmm. So this A means the size of the cells or batteries, okay? Fine. So listen, types of cell is not that simple. As you all are in grade 6, but I'll tell you little more deeper for the types of cell. So in the next class, I'll show you types of cell and their uses and how they consume electric energy, how they are used up. Okay. No worries. So let's move to next topic. I'm sharing the PPT. Is it visible?
Yes, ma'am.
Yes, ma'am.
Okay. Yesterday we were doing electric cell features.
Yes, ma'am.
So electric cell, the last point is, it converts chemical energy into electrical energy. When the chemicals are exhausted, the cell stops working. Next is electric bulb and its features. So now at times we have what type of, light bulbs, if you can tell me. Now we have fluoro lamps, CFNs,
Ma'am, LED.
LEDs, very good. Give me a minute. CFL, LEDs, any more? Okay, so the bulb shown in the picture is actually a type of bulb which was used when it was, when Thomas Edison just made up the bulb. Okay, so this basic bulb has a structure. This basic bulb is made up of glass. This outer covering is made up of glass. This metallic ring type structure is called the base. Okay. Now in between, you see these two types of strands here, and these are connected with a very thin and light wire. This is the very thin and light wire here. Like if we slightly gently shake the bulb, this wire will start shaking with the bulb. Okay. And the main lead role is of this material only, which is made up of tungsten. It is made up of special element. We cannot make it of iron, copper, silver, gold, normal. No, tungsten has special properties. See, what a bulb does basically, it consumes electric energy. It takes up electrical energy
Ma'am,
and
and changes it
and gives
into
us
light energy.
light. Actually, this bulb, also converted the electrical energy into some heat. Light plus heat also. This bulb used to get heat up. Not much. Light was the major part. Heat was the lesser part. Okay. So why tungsten? Because when the one of the terminal is here, this is you can say a positive terminal, and this part is negative terminal. So when the current starts flowing from positive to negative, it reaches through this wire to this tungsten filament. This filament is a general name. Tungsten is a specific name of material, right? When the current passes through this, it starts glowing. So this material itself starts glowing, gives us light when the current passes through it. And can you imagine how much it gets heated? It gets heated up to, you can say, like 4,000 degrees Celsius. This is the value of heating up, but still it does not melt. This is special about the material tungsten. Is it okay?
Okay, ma'am.
Yes, ma'am.
So the outer covering of the bulb is glass and the base is metallic. Base means the ring type structure. Next, the glowing part of bulb is called the filament and is made up of tungsten. The filament is attached to two wires. One of the wire is connected to metal case at the base, and the other wire is connected to metal wire at the center of base. Okay, these two.
Ma'am, why the bulb will heat up, ma'am?
Pardon?
Why the bulb will heat up, ma'am?
Why the bulb heats up? Here, this is the bulb which was the very first bulb made by Thomas Edison. So he only was able to found the material which on passing of electric current through that material will give us light.
Okay, ma'am.
Okay.
It
Yeah.
stops the filament stops the electricity and creates friction, right?
Not able to get you. Repeat your question loudly, please.
Not question, ma'am. Like if the electricity pass through the filament, the filament stops the electricity. Tries to stop the electricity, right?
No, it does
Generating
not stop.
friction.
No. It does not stop electricity, dear. I should say this is a property. See, if I talk about, silver or copper material, they are such good conductors that if we pass the current through them, they will allow the complete current to pass through them, and they will act as a like transmission material for the current passing. But tungsten is the material which does not allow the current. Then if we are giving this tungsten a very large amount of current means type of electric energy. If we are providing this energy to tungsten forcefully, where this will current go? Tungsten is not allowing the current to pass, then where will that electric energy go? This electric, if you have heard this line that energy is neither created nor destroyed, it only transforms from one form to another. So where this electrical energy will transform, this whole energy of current gets transformed into light energy. Is it
Okay, ma'am.
fine?
Ma'am, the
This is
filament
just the
itself,
transmission of electric energy to light energy and heat up.
ma'am, the filament itself is made up of tungsten. So
Yes, yeah. Nice. So base of the bulb and the metal tip are the terminals of bulb and they do not touch each other. The main part is the diagram of this bulb. The current electrical energy gets converted to light plus heat. Okay. So draw this diagram. The diagram of electric cell also, although cell you have seen yesterday means the actual cell, you know that, but still you can write metal cap, positive terminal and all the label part. Note it down.
Ma'am, should we write electric bulb?
Yeah, electric bulb features also.
Ma'am, should I draw?
Yes, first draw the written part. You can leave, you can write it later on, but the diagram with complete label, please draw it.
Ma'am, we should draw the bulb also.
Yes.
Okay, ma'am.
ma'am, can you erase the lines on the filament? I can't see the filament. Can you erase the lines on the diagram?
Should I clear the annotation of diagram?
Yes, ma'am.
Okay.
Thank you, ma'am.
Noted.
I'm done drawing the bulb.
Ma'am, now I started drawing the bulb.
I mean to draw that battery also.
Yeah, you can. Be quick, please.
Ma'am, done drawing both.
Ma'am, not over 1 minute.
Ma'am, we need to only draw or write. Ma'am, we need to only draw or write.
The writing part is, you can leave writing part for now because I'll be uploading PPT. You can, note down from there.
Okay, ma'am.
Right now,
Ma'am,
just draw the diagram.
Ma'am, 1 minute on drawing.
Ma'am, diagrams over. Should I write electric bulb futures?
No, not right now. Please don't waste time, You can write it later on. It will be available to you on in the classroom.
Ma'am, then finished, ma'am.
Should I proceed?
Yes, ma'am.
Should I proceed?
Ma'am, 1 minute, I'm drawing the battery.
Types of cell I'll be showing you in the next class. So let me tell you the advancements in the bulbs, beginning from that incandescent bulb, which was used in the very beginning. The types of bulbs are, first is incandescent bulb. The very first bulbs were of this kind. Next came, halogen bulbs. Halogen is a type of gas actually. So a gas used to be filled inside this glass case inside bulb in halogen bulbs. And when electric current passes through that gas molecules, they give spark. So they release light. Okay. Next came CFL, chlorofluoro lamps. It was again filled with some sort of chemicals which gives off light. And later on now, we are mostly equipped with LEDs in our homes, light emitting diodes. Okay, CFL stands for compact fluorescent lamp. Compact fluorescent lamp. And LED stands for light emitting. Light and emitting are different words, diode. Please note down the 4 types of bulbs. LED is the 4th and the latest one, which we are using nowadays.
What's the spelling of
Pardon?
fluorescent?
Speak loudly.
Ma'am, what's the spelling of fluorescent?
Dear, it comes in different colors. Compact means like smaller in size. When, of course, this CFLs used to be, have longer life and less electricity consuming. So CFL were the best of those. And yes, of course, because now we are equipped with LEDs, light emitting diode, because of, we became free of the gases. We became free of the chemicals totally. Light emitting diodes use a diode, means it is a type of semiconductor. Now, what is semiconductor? You must be aware of metals and non-metals that exist in nature. So semiconductor is a type of material which has properties in between those of metals and non-metals. These are neither totally metal, these are nor totally non-metals. They are the property that when light passes, then when current passes through the diode, they emit light. So it is chip kind of material.
Ma'am, over.
Written all 4?
Yes, ma'am, drawing also completed.
Okay. So do one thing, that if you can get the picture of these 4, if they are at your home, either the waste one, okay, please get the picture of these 4 types of bulbs. You can take the help of your parents, right?
Yes, ma'am.
Do not get it from the Google. No, get it from your home. If you do not have any one of these, it's okay. 2 or 3, whatever you have at home now, waste one or the fine one, just click a picture, make a simple collage of 4 pictures and write your name and class. That's it. So that you can have idea, and you can write the name also with that types of bulb. Getting?
Yes, ma'am.
So this is
Ma'am,
a activity for homework. Yeah?
ma'am, is this our homework?
Yes, this is your homework. To find these bulbs, click the picture, make the collage, and send it to me.
Ma'am, I didn't understand, ma'am.
What you didn't understand?
Homework, ma'am.
Dear, see, these four which I have written here, these are the types of bulbs.
Yes, ma'am.
Okay, types of lights which we used to install in our homes. Incandescent were the very first bulb, you can say around like 100 years ago. Okay, then
Okay,
came
ma'am.
the advancement halogen bulb. After then we installed chlorofluoro lamp CFL, and finally now at times we are using LEDs. Is it okay?
Okay, ma'am. We
So
need to.
get the picture, click the picture of these four bulbs if you have in our home. You can take the help of your elder brother, sister, or parents, or anyone. Click
Okay,
the
ma'am.
picture, make a small collage, and on that collage, I hope you are well familiar with how to make collage. Every smartphone has this feature. Simple of 4 photos. Write the name of the bulbs with them, and at the bottom right corner, write your name in class and send it in the group.
Okay, ma'am.
Okay. Means
Okay.
I want you to be aware and know what these bulbs used to look like and how they used to work by the help of gas, by the help of any solid material, by the help of chemicals, etc.
Okay, ma'am.
Okay, fine. So should I stop sharing? I need to share another PPT.
Yes, ma'am.
Okay. Why don't you keep your cameras on? Oh, next PPT is here. Electric circuit. Suppose you have a simple electric wire. Okay, you have a simple electric bulb. Next time in the next class, you have to be ready with the following material for the activity. I'm just writing here, hold on. Electric wire, you can say 2 pieces. 2 small pieces are enough. Next, you need to get a cell or a battery. Next, you need to get a small electric bulb or simply an LED. One LED. Is it okay?
Yes, ma'am.
So we will be performing this activity in the next class whenever we'll have in the next week.
Okay, ma'am.
Look here, when we connect the positive terminal of the cell to the one end of the bulb and negative terminal of the cell to the other end of the bulb. Okay, what happens? See how the cell works. Do you know what is present inside the cell that it allows the appliance to work? It allows the bulb to glow. It allows the fan to move. What is present inside the bulb?
Ma'am, like one
Electricity.
rod. Ma'am, a rod in the middle.
In the cell, I am asking.
Ma'am,
Ma'am,
electricity.
electricity and chemicals.
Chemicals. Actually, we should say chemicals are present, which allows electricity to
Generate.
in the picture. Okay, so chemicals are there. Now, what is meant by positive and negative? Listen very carefully. How the cells work. Suppose I have two buckets. Okay, one bucket is filled with the water up to its brim, and second bucket of same size is half filled, half, or you can say one third filled only. Now, if I connect the pipe, okay, in between the two buckets, will you observe water flow from first to second?
Yes, ma'am.
Okay. Now, after this, the first has become half, and the second is, second is also become half now. It is filled. Now, if we connect the wire between the two, will you see any flow of water in between two?
No,
No.
ma'am.
Yes, ma'am.
Yes, still there will be water flow from first to second.
Yes, ma'am.
Who says yes?
Ma'am, me, Aksha. Sorry.
Akshin says yes. Neha, Bhavesh, and Harshit.
No, ma'am.
Maybe for some time it will flow. After some time, the second bucket will be more than first bucket, so that the water will not flow.
Okay. Let's assume that the water keeps on flowing from first to second. Just a second. Let's say that water keeps on flowing from first to second. First got full empty and second got fully filled. Now how will the water flow from first to second? Or you mean to say that now water will flow from second to first? What do you think?
So, ma'am, it will flow again to
Dear,
second.
see, in this case, when the water in both the buckets became up to the same level, there will be no more water flow from first to second. Got it?
Yes, ma'am.
For the water to flow, the levels in the two buckets should be different. One should at greater level, other should be at lesser levels. So the positive and negative terminals of these at these cells mean that one side has maximum charge, positive side. You can say on the number line, if I draw 0 here, this is 2, this is 2, this is 4, this is 6. And on the negative side, I have -2, -4, -6. It's like -6 and +6. This is the positive terminal of battery and -6 is the negative terminal of battery. So this difference makes the current flow. That's why it is written negative and positive. So the current starts flowing from the positive terminal of the battery. It moves to the one of the ends of the electric appliance, let's say bulb. It passes to the other end and then finally moves to the second terminal, negative terminal of the cell through this wire. And this gives the path for the current to flow because current needs paths only. Current is already present inside this, bulb. But if we disconnect the wire, current has no path. How will the electricity flow? How will the current flow? And how will our plants work? It's very much like this two buckets of water. If we do not have pipe, if we have not connected the two buckets, will there be any flow of water?
No, ma'am.
No, no. So that's how an electric cell or a battery works. Understood?
Yes, ma'am.
Fine. So look here, electric circuit means the complete path from one terminal of the cell through the bulb and back to the other terminal of the electric cell is called the electric circuit. So this complete path, including the cell or a battery, which is actually providing us the current, and this appliance which we want to run. Okay, this all the things in this circuit is called the electric circuit. Okay.
Yes, ma'am.
Fine. Please write down electric circuit and draw this basic diagram on the right hand side.
Ma'am, we need to do that battery one at the top.
This, the first one at the top.
Ma'am, should
Ma'am,
we
and also write
Ma'am.
electric circuit.
Electric circuit, yeah, also write down.
Okay, ma'am.
Write one more point that electric cells contain chemicals which provide us electricity. Electric cell has chemicals which provides us electricity. Be quick, please.
Ma'am, we need to write about only electric circuit.
Yes, only electric circuit.
Done, ma'am.
All of you?
Ma'am, I'm doing the diagram.
Okay.
Ma'am, I'm writing ma'am the diagram over.
Okay. Please be ready in the next class with two small pieces of electric wire. Okay. That should be the insulation should be kept off from the two ends. Okay. So as to connect it, a cell or a battery, normal a cell will work. If a small LED is there, a cell will
Done,
work.
ma'am.
If you have a bigger bulb, then battery will be required. So try to get a small single LED. These three things are required. Then we'll perform an activity in the next class. Okay.
Done, ma'am.
Okay, ma'am.
Okay. Fine. Bye-bye. We'll meet next week. Okay.
Okay, ma'am.
Bye. Have a nice day.
Thank you, ma'am. Have a nice